In a previous lecture, we talked about doing a single sample test on a mean using the z-test. This assumes that we know the variance, and so we can use a normal distribution as a sampling distribution. However, that's not the full story. When we're testing means, we really are estimating two things, both the mean and the variance. So the variance is not a constant that we know. Estimating the variance introduces additional variation, which complicates the situation. Fortunately, William Gossett allowed for this by inventing the t-distribution, which takes that additional variation into account. The t-distribution is flatter and wider than the Gaussian, depending on the degrees of freedom, which is just sample size less 1. We can see here that there's an entire family of curves that get higher and higher, peakier and peakier, as the sample size increases until it converges to the normal distribution. To use this, there's no big change in the test statistic. In fact, we calculated exactly the same way, substituting sample variance for known variance, and we call it a t-distribution, a t-statistic following the t-distribution. Let's look at some examples. They're not terribly complicated. So, we're going to test whether or not the mean is less than 14 compared to a null of 14 or greater. We'll do that at the 5% level. And our sample statistics will have a sample size of 36, a sample mean of 13.1, and a sample variance of 9. Now, we need to look up the critical value from the t-table. We see 35 degrees of freedom with a 5% tail. We put a minus sign on the front because we're looking at the less than 14 side of the curve. And when we look that up in the table, we get a critical value of minus 1.69. During the calculation, well, it's obviously negative. Let's see. Square root of 36 is 6, and the square root of 9 is 3, so that's 2. 2 times 0.9 is minus 1.8, and we see that we reject the null. Since this is actually less than minus 1.69. Let's do a two-sided version. Now we'll compare 14 to not 14, so a two-sided test. This time the sample size is 100, the sample mean is 14.6, and again the sample variance is 9. Now we have to, of course, take the 5% and split it in half. So we have 2.5% on the low end, 2.5% on the high end. And notice we've got a minus side and a plus side. So now we have a plus or minus. We look up at 2.5% tail for the t-statistic with 99 degrees of freedom. We get 1.8985, plus or minus, of course. When we calculate our t-statistic, that's t, not z, we get 10 times 0.6, so 6 over 3, we get 2.0. And again, we reject the null because 2.0 is greater than 1.985.